Hi everyone, my name is Cade White, and today I will be going over my ECON 402 final project. My paper is titled Examining Environmental and Situational Correlates with NFL Field Goal Success. So looking at my research question, I analyzed what situational factors most affect the probability of NFL field goal success. Environmental impacts are also analyzed. And then I will examine the literature analyzing the effect of icing the kicker. Icing is a common strategy used in late game NFL situations, and it refers to the process of calling a timeout before a kicker attempts a potential game winning or tying field goal late in the game, typically 2 minutes or less. And this timeout is usually called by the opposing team, and the thought process and methodology behind this will be discussed further on. Situational variables in my analysis include field goal distance, time remaining in the game, and score differential. And environmental effects are controlled using a wind speed variable, which is only present in outdoor games. So my data was obtained from the NFL Faster repository of NFL play-by-play data. The repository has play-by-play data dating back to 1999. However, in my analysis, I use data from 2008 to 2020, and this is because 2008 is the first year that environmental variables were introduced, such as weather and wind speed. NFL Faster is an open source R package developed by Sebastian Carl and Ben Baldwin. It builds upon the package NFL Scraper, built by Horowitz, Yurko, and Ventura by adding advanced metrics, and it also obtains play-by-play data much faster, as suggested by the package name. The repository data was originally scraped from NFL.com and Pro Football Reference. These are both very credible sources, and because of this, I do not anticipate errors in variable bias resulting from measurement error. Since I only use data dating back to 2008, there are also no missing observations in my analysis. And lastly, selection bias does not seem prominent in this case. Icing is typically only used in the NFL, so using only NFL play-by-play data should not affect my results. This data set is very robust. It contains 363 variables. To start, I had 625,578 observations, which in this case is plays. Each observation represents a play spanning from 2008 to 2020. And because my research question involves kick success, I created a new data set containing only plays which were field goals, which left only 13,340 observations. The dependent variable of interest in my study, field goal result, was originally a string variable containing values of made, miss, and blocked. And I recoded this string variable to a binary variable I called miss, which takes a value of 1 if a given kick was missed and 0 if it was made. I also omitted all blocked field goals from my analysis and data set, which narrowed my data down to 13,067 observations. And I omitted all blocked field goals because I believe a blocked kick is typically not indicative of a kicker's performance. It's usually outside of their control. So including blocked kicks as a miss may have skewed my results. In my final data set of over 13,000 observations, the make percentage in my sample was about 85.6%. This is shown in the following descriptive statistic table seen on the slides. The mean of my dependent variable miss is 0.1438. In other words, about 14.4% of kicks were missed, which corresponds with a make percentage of 85.6%. The average kick distance in my sample is about 38 yards with a max of 76. Wind speed ranged anywhere from 0 miles per hour to 71 with an average of 8.3 miles per hour. We can also see score differential taking both positive and negative values. Score differential measures the difference in score between the home and away team at the start of the play observed. A team can either be up or down, which explains the negative and positive values. Moving on to my literature review, the amount of literature regarding this specific research question is sparse compared to some other topics in sports research. However, some prominent papers have been published. Looking first at Goldschmied, Mencken, and Caffrey's paper titled Pressure Kicks in the NFL, an archival exploration into the deployment of timeouts and other environmental correlates. They used archival data of pressure kicks from 6 consecutive NFL seasons from 2002 to 2008 and employed a mixed effects hierarchical linear model. Their data was obtained from the NFL Scraper package, the predecessor to my data, essentially. They found that icing the kicker was successful in reducing scoring, while other environmental factors such as experience, game location, and game score were not associated with conversion success. Along with this, they found that if a timeout before the pressure kick is requested by the coaches of the kicking team, in other words, if the kicker's own team called the timeout before the kick, kickers were not subjected to the debilitating effects of icing. The authors limited the sample of kicks to only those cases where the kicker realized that the game outcome was dependent on his success and that future plays that might reverse the score was highly unlikely. In other words, they limited the sample of kicks to late game kicks where it was a very close game. They determined pressure kicks. They broke them into 2 groups: when a kicker's team is 3 points behind and when the score is tied before a pressure kick. Their final conclusion found that while iced kickers managed to score only in 64.4% of their attempts, the success rate was much higher at 80.4% when the kicker was not iced. Self-icing, when a timeout is called by the kicker's own team, did not have empirical support of affecting kick success. This concept of self-icing and its lack of effect in their paper raises questions about the method of action behind icing's apparent success. The first proposed and most prominent theory behind icing working is rumination, which is the act of thinking about negative outcomes, in this case, missing a kick as time goes on. The longer wait times after a timeout provide more opportunities for kickers' rumination. Several experiments have demonstrated that rumination increases negative thinking and impairs problem solving. For more info on this, refer to Tucker, Caldwell, and Berg's 1999 paper. Jordet, Hartman, and Sigmundstad demonstrated that longer times of waiting for the referee to signal to kick were associated with more misses in soccer matches. And Whitehead and colleagues' 1996 paper found that in NCAA Division I men's basketball, free throw shots were more frequently overthrown when attempted during crucial rather than non-crucial game situations, which kind of controls for and shows the effect of so-called choking in sports. However, in my opinion, if rumination is at the core of icing's debilitating effects, we would expect self-icing to be equally effective. Who calls the timeout before a play should not have any effect on a kicker's increased anxiety about kicking. In other words, if your own coach calls the timeout, you still have that a minute and a half to ruminate about the negative outcomes of the kick. So Goldschmied finding that self-icing was not significant, I think dismisses some of the theories about rumination being behind icing. While Goldschmied and colleagues found icing to be effective, some NFL kickers disagree. Jason Elam, a former Denver Broncos kicker, stated that the few extra moments afforded by a timeout gives kickers more time to prepare, and they can better consider wind, distance, and ball placement, and take a few more practice kicks. Along with this, former Giants kicker Lawrence Tynes believes icing is ineffective. He stated that the timeout allows him to go to the sideline, get positive reinforcement from his team, and essentially visualize the kick, and he thinks it actually helps him make it. So these kickers' opinions Given this, icing may not only be effective in lowering make probability, but it might actually raise it. Based on this, 2 other papers agree with Tynes and Elam and found significantly different results than those in Goldschmidt's paper. Going for 3, predicting the likelihood of field goal success with logistic regression by Clark, Johnson, and Stimson found no significance in icing the kicker. And the article, Choking Under the Pressure of Competition, a complete statistical investigation of pressure kicks in the NFL from 2000 to 2017 by Chang and colleagues, attempted to replicate the findings in Johnson's paper. And while they found drastically different significant variables, it was also concluded that icing has no debilitating effect on kickers' performance in pressure situations. So in short, the literature is varied. Some articles find that icing is effective while others do not. Moving on to my methodology of my study, due to the nature of my dependent variable, which is binary, I chose to deploy OLS regression along with 2 other models. While I hope to analyze the effects of icing on kick success, lack of data on timeouts being called prohibited this. So to control for the effect of rumination on game outcome, I included score differential as an explanatory variable in some of my models. This is because I would expect as the score differential is low, rumination and anxiety before a kick would be higher. My dependent variable miss is binary. It takes only 0 or 1 values. The first independent variable I chose to include in my models was kick distance. Intuitively, the longer the kick distance, the higher the likelihood of a miss. In the case of my models, kick distance should have a positive coefficient. I also expected this variable to be extremely statistically significant. The first model I ran was a linear probability model with kick distance as the only explanatory variable. The linear probability model is the same as an ordinary least squares regression model, essentially. The fitted line is obtained from minimizing the sum of squared residuals, same as OLS. The interpretation of this model is also the same as OLS. A 1 unit increase in X is associated with a beta increase in the dependent variable. However, in this case, the dependent variable models a probability as it lies between 0 and 1. The following scatter plot shows my linear regression model. The problem with this linear model is it theoretically can predict values less than 0 or greater than 1, which is not possible for probability. Looking at the R squared of a linear probability model also raises issues. Because our dependent variable is binary, a linear fitted line will typically have a low R squared and not explain the variance in the dependent variable well. Because of this, I chose to employ nonlinear models. The probit model is a fitting model when dealing with a binary dependent variable. Probit regression forces the predicted values to be between 0 and 1. This scatter plot depicts the nonlinear nature of a probit regression, and it fits the data a lot better. I also ran a logit regression model, which is essentially the same for all intensive purposes. And this is shown by the next scatter plot here. As you can see, they're essentially the same. These nonlinear models employ maximum likelihood estimation instead of OLS to obtain the beta coefficients. Because maximum likelihood estimation chooses the unknown coefficients to maximize the likelihood function, which in turn is the joint PDF. In effect, MLE chooses the value of the parameters to maximize the probability of drawing the data that are actually observed. Interpretation of these 2 models is different from an OLS regression due to their nonlinear nature. The effect of a change in X depends on the starting value of X, which I will demonstrate later on. Measures of fit are also different for logit and probit models. In my analysis, I chose to employ pseudo R squared to gauge goodness of fit. However, standard hypothesis test and statistical inference remain the same in these models. Moving on to the interpretation of my models, looking first at the linear probability model, we can see that kick distance is statistically significant with a positive coefficient, indicating that as kick distance increases, the probability of a miss also increases. For every 1 unit increase in kick distance, which is equal to 1 yard, we observe on average a 1.12% increase in miss probability. Now let's look at the logistic regression model, only regressing on kick distance. The effect of kick distance on miss probability is once again statistically different from zero. Because this is a nonlinear model, the interpretation is different, however. To interpret the logit model, you need to plug two values into the regression equation and take the difference in the predicted values. This difference is the estimated change in miss probability in this case. And the F that you see in the slides in this logit regression equation represents the logistic distribution. The next model I ran was a probit model with kick distance as the only dependent variable. The interpretation of a probit model is the same as a logit. However, instead of a logistic distribution, phi in the following equation represents a normal distribution. The magnitude of the coefficients is relatively the same in this model as the logit model, as we expect. Although beta 1 almost doubles, so did the intercept. So essentially they're the same. I ran this model essentially to show the similarity of these two nonlinear model estimates. The fourth model I ran was once again a probit regression, this time with wind included to control for weather and environmental factors. In this regression, both kick distance and wind are statistically significant, meaning they have a non-zero effect on miss probability. Wind has a positive coefficient as expected. In other words, as wind increases, so does the probability of a missed kick. And my last model ran included the variable score differential. This is once again a probit model. I included this to control for rumination and potential choking as outlined in my previous literature review. Score differential was not statistically significant at any level. While this variable does not perfectly capture the effects of icing, I believe it does capture potential rumination effects on a field goal kicker. A closer game would imply more negative outcomes of a miss, leading to rumination and anxiety. However, this variable showed no effect on kick probability. In conclusion, using robust play-by-play data, I hoped to capture what situational and environmental variables most affect the probability of kick success. Not surprisingly, kick distance and weather were statistically significant in altering kick success. However, score differential was not. In the future, I hope to report these results while controlling for a timeout being called before the kick, also known as icing. While there may be threats to internal and external validity in this study, I believe this analysis can prove beneficial to NFL coaches and players alike.